MAP4C 5.1 Trends in Data. So what we're going to do is investigate the way that linear, quadratic, and exponential relations appear as an equation, a graph, and a table of values. So we've discussed in section 5.0 what each of the equations look like, the graph, but what we are adding is the first differences represent, if we were to have a table of values, the difference y2 minus y1. So 50 minus 40 is equal to 10, 60 minus 50 is equal to 10. And we're seeing that for every increment, in this case it's 1, but for every increment that we move over, the rise is the same. That's what the first differences means. And if each of the first differences are equal, then we have that rate of change, a linear relation. Quadratic relations. So we discussed the three different forms. And what is unifying them is that they're all degree 2. Technically, the x term has a squared value for each of these. Notice that in factored form, we don't have a squared term directly, but if we were to multiply this binomial times this binomial, when we use FOIL, the first term would be x times x, which is x squared. So, important features of a parabola to discuss: x-intercepts, y-intercept, vertex, and the axis of symmetry. That's like a mirror image on the left and right hand side where the curve is symmetrical. So these second differences are achieved by doing the following. Our first differences by subtracting adjacent points. 1 minus 0 is 1, 4 minus 1 is 3, 9 minus 4 is 5, and so on. These second differences are the differences of the differences. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So you can have a test for a table of values to determine whether or not it is a quadratic relation is complete a second differences test, and if they're all equal, it's quadratic. If they are not all equal, the relation is not quadratic. Lastly, exponential relations. So we determine that that b factor is the number that is used to multiply from one stage to the next to get another number. So the relationship we test for is the ratio of adjacent points. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2, and so on. So this indicates that if we have constant ratios, the relationship is exponential.